All right, guys. Sorry for that interruption. Just to summarize what we were kind of talking about as the announcements interrupted this first video, um, I think we were able to get through holes without any trouble. When we got to vertical asymptotes, we started to get interrupted. Keep in mind, vertical asymptotes come from any factors left in your denominator. And so looking at this one through x equals -4, notice that's a vertical line when you write that as an equation. Versus kind of that last thing that we talked about with roots. And then remember, another word for roots are your x-intercepts. And so kind of keep that in mind as you're looking at it here. And so notice that when you write each of those, they kind of represent different things. Asymptotes will always be the equation of a line, so x equals or y equals. Holes and roots are points, so make sure you write those as an ordered pair. So let's take a look at some examples here, and these will be the only two we work through today. It says determine the x values for any holes or asymptotes, and then find any roots and horizontal or slant asymptotes, and sketch a graph of the function. So I'll just kind of let you kind of know what my kind of first preference is. I always look for my horizontal asymptotes first. And by horizontal asymptotes, I mean I'm looking at numerator versus denominator. My degrees are the same. If they're the same, I look at my leading coefficients in order to decide what my horizontal asymptote is. For this particular problem, that means that y equals 1 is going to be where my horizontal asymptote is. Once I've done that, then I start to look for kind of my factors. In fact, another thing I'll sometimes look at is y-intercepts. The y-intercept, if you were to put 0 in for x, if you think about what that would do, that would mean that this is 0, this is 0, this is 0. All you have is 8 over -16, which is 0, -1/2 if you were to simplify. And so I'll just kind of look at those two things first, since I can look at those directly from my equation without having to factor. And then now I'm going to go ahead and start to factor everything. So x minus 4x minus 2 for my numerator, x minus 4x plus 4 for my denominator. So when I look to simplify, my x minus 4s are going to divide out, which tells me that I have a hole at an x value of 4. Notice that I'm starting to write my hole as a point. I need to figure out what the y value is. So the y value for my hole, the y value be equal to putting 4 into my remaining function. So 4 minus 2 over 4 plus 4 ends up being 2 over 8, which reduces to be 1 over 4. So my hole for this one is going to be at a value of 4, 1/4. For my next thing that I'm going to look for with my vertical asymptotes, I've got x plus 4 as a factor of my denominator. So looking at vertical asymptotes, I would set that equal to 0. And so x equals -4 is going to be kind of my vertical asymptote here. Last thing is going to be my roots. So with roots, I've got x minus 2, which means that I'm going to have a root at 2, 0. So now I get to go through and start to graph kind of everything that I've got. So looking at kind of my y-intercept, that's the point 0, -1/2. I have a horizontal asymptote through y equals 1, so I'm going to go ahead and graph that in here. For my remaining kind of information, let's see, vertical asymptote through x equals -4. So -1, 2, 3, 4. So -4 here is going to be where I put that vertical asymptote. And then I've got 2 more points I can graph. I've got 4, +1/4. So 1, 2, 3, 4, 1/4 would be about right here. And when I graph my hole, let me try to do that a little bit better for us here. But that needs to definitely be a noticeable hole, so it needs to look like an open point as opposed to being a filled-in point. And then I've got one last point at a root of 2, 0, which would be about right here. So using all that information, that'll kind of tell me what the shape is, at least on this kind of right side of my graph. So if you notice, I'm going to kind of draw a line through those points. I also need to graph the left side of my graph. And if you notice, there's nothing to the left of this vertical asymptote that I can use as a point. So I'm going to have to start to kind of do what's called testing a point, which basically means just pick any x value to the left of -4. I'm going to pick an x value of -5 to test a point. And basically what I'm going to do is I'm going to put -5 into my remaining function up here. So I'm going to say -5 minus 2 over -5 plus 4 becomes negative 7 over negative 1 or positive 7. In other words, another point that I can graph now is going to be negative 5 comma 7. So if I go negative 5 right here, positive 7 right here, that tells me that this portion of my graph is going to be up in this section, and it's going to look something kind of like this. All right, we got one more example we're going to look at, and then we're going to call it a day here. So on number 8, we're going to do kind of the same thing, starting with kind of looking for our horizontal asymptote first. And this time, if you notice, degree of the numerator is greater than degree of the denominator. And so unfortunately, that means that we're going to have some work to do in order to find our horizontal, which in this case is going to be more of a slant asymptote. And so if I'm going to go ahead and do my division here, and let's kind of see what we come up with. So x squared minus 4 is going to be what goes outside our division symbol. And then x cubed minus 4x is going to be what goes inside. Don't forget about your placeholders, so 0x squared and 0 over here. And then let's see, x squared, to get it to match it up with x to the third, I'd have to multiply by x. So that would get me x to the third and a negative 4x here. And so then I go ahead and let's change our signs, minus and plus. I get 0 when I subtract there, 0 there, 0 there. So really I get a remainder of 0. So 0 over x squared minus 4 is kind of what I end up with. In other words, what I'm going to have is I'm going to have kind of this slant asymptote through y equals x is going to be basically what that is. And so really here's where it gets to be kind of interesting as you look at it. At this point, what I would recommend doing is I would recommend grabbing a graphing calculator and kind of seeing what the graph looks like on that. It's actually kind of interesting, kind of what's happening there. So if you want to go ahead and graph that real quick on your graphing calculator, what you're actually going to see is that slant asymptote is essentially what your function looks like. Is that really what's happening here is that your function is basically following a line through y equals x, which is kind of interesting. And so, tell you what, since we don't want to really study a line, there's really not much to that. I'm going to kind of change our original equation just a little bit. And so instead of x squared, or x to the third minus 4x, what I'm going to change that to is I'm going to change that to x to the third. And then let's change this to be x to the third minus 25x. Is going to be what I want to change that to, over x squared minus 4. Just so we can see something that's a little bit kind of more rational function looking. And so in doing that, let's kind of see what we end up with. We're going to kind of set up that long division once again, x squared minus 4 on the outside. X cubed plus 0x squared minus 25x plus 0 on the inside. Once again, you're going to multiply by x to get your x to the thirds to match up, and then your minus 4x. At which point, let's see, change my signs, minus plus, x to the third minus x to the third is 0. 0x squared has nothing to combine with. So then I've got a negative 21x as my remainder, so plus a negative 21x over x squared minus 4. At which point, to talk about a couple things. Notice this time we still have that kind of slant asymptote of y equals x. So again, instead of horizontal, this is going to be a slant asymptote through y equals x. You actually can't have a slant and a horizontal asymptote at the same time. And then here's our remaining function that we're going to be working with. It's going to be the negative 21x over x squared minus 4, which I'm just going to factor at this point to be x plus 2x minus 2. To talk about a couple things at this point, let's look at y-intercept first, since that's usually something I'll do at the beginning. If you were to replace everything with an x with 0, you basically end up with 0 over negative 4. And so your y-intercept ends up being at 0, 0. If you notice, for your roots then, you set any factors in the numerator that are left equal to 0. So you set x equal to 0. And you've already got your roots as well. It's going to be a root at 0, 0. And so then we start to look for a couple other things. For holes, there's not going to be any holes since there was no factors that canceled out for both. But for vertical asymptotes, there's going to be a couple of those, which is going to be through x equals negative 2 and x equals positive 2. So at this point, I'm going to go ahead and start kind of graphing some of that stuff in here. So here is my vertical asymptote through -2. Here is my vertical asymptote through +2. I've got my slant asymptote through y equals x. So here that is there for us. And then I've got a root here at 0, 0. So at this point, what I'm going to have to start to do is I'm going to have to check lots of points, because if you notice, I really don't have a lot of information about my graph. I'm going to try the point -3 first. So if I put x equals -3 into my equation that's kind of left over, I'm going to end up with -21 multiplied by -3 over, I'm going to use x squared minus 4 in place of x plus 2x minus 2. In other words, -3 squared minus 4. So this ends up being a positive 63 over -3 squared is 9. 9 minus 4 is 5. And 63 over 5 reduces to be, and since we're graphing, I'll think of it as a decimal, 12.6. And notice that if I were to graph that, then -3, 12.6 would be kind of somewhere up in here. In other words, my graph is going to look something kind of like this. So it's going to be up in this top section. I'm then going to test a point kind of for this right side of my graph. And so testing a point there, I'm going to put in, let's say, an x value of +3 this time. And we'll kind of see how that's different. So -21 multiplied by +3 over +3 squared minus 4. So notice that this time I end up with -63 over 5, which would be a -12.6. So for this one, having a point kind of down in here somewhere, I'm going to have a graph that looks something kind of more like this. Now I still have this middle section to kind of worry about. And really, there's a couple different shapes. You can either have kind of a cubic looking graph that looks something kind of like this, or you can have it going in the opposite direction looking somewhat like this. To be able to tell kind of which of those two scenarios it's going to follow, I'm going to test a couple additional points. I'm going to test x equals -1 and also test x equals +1. So with -1, I have -21 multiplied by -1 over -1 squared minus 4. That reduces to be 21 over 1 minus 4 is a -3. In other words, -1 comma -7 is going to be one of my points right here. If I test +1, so here I'm going to test x equals +1, I end up with -21 multiplied by +1 over 1 squared minus 4. That becomes -21 over -3, which reduces to be +7, which gives me a point right here. At which point now I can start to kind of see that my graph is going to be the second of those two options we were considering, which is going to be similar to kind of a cubic shape in the middle of our graph. All right, guys, that's all I've got for you as far as notes for today. Please be sure that you've captured everything from both these videos. There will be some notes on Schoology for you to look at as well. Just to kind of give you an idea too, there is homework tonight over what we just talked about today, so graphing. So keep an eye out for that on Schoology somewhere to see if that's going to be on Big Ideas or through Schoology. As far as our schedule for next week, Wednesday is going to be a tea day for us. So on that day, we are going to end up, we're going to do some review of graphing. And then Friday on the block day, so that'll be an O day for us. We won't meet on Thursday. We're going to take your quiz for these sections of the notes, as well as kind of start an intro to radicals. So that's kind of what to expect next week, and I will see you then. Have a great weekend, guys.